Welcome viewers, in this video we will see the details about hybrid parameters coming under two-port network. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic, two-port network in that hybrid parameters, H parameters. Hybrid parameter or H parameters find the extensive use in the transistor circuit. The transistor circuit we are using this H parameter. They are well suited to transistor circuit as well as these parameter can be mostly conveniently measured. So this mostly used in the transistor circuit to measure these parameters. Now we'll see what is the hybrid parameter. The hybrid matrices describe a two-port network when the voltage of one port and the current of other port are taken as a independent variable. Normally in the two-port network we have Z parameter, Y parameter, that is impedance, admittance parameters available. In that, current and voltage of input port is expressed in terms of current and voltage of output port. Normally we will use like this. Input port as dependent variable, output was a independent variable, like that will take. But in this hybrid, so the name itself, hybrid means the current of one port and voltage of another port is expressed in terms of, is taken as a independent variable, so that it is called a hybrid variable. Right? Normally in the input port current and voltage expressed in terms of output port current and voltage. But here what we are doing, voltage in one port and current in another port. That's why it is called a hybrid parameter. Now we'll see the block diagram. So this is the, consider this network, two-port network. 1 dash input port, 2 dash output port. V1 I1 is the input port current and voltage and current. V2 and I2 is the output port voltage and current. So if the voltage at the input port 1 dash and current at the output port 2 dash are taken as a dependent variable, we can express in terms of I1 and V2. So what we are doing, V1 from input port and I2 from output port is expressed in terms of I1 and V2. So this is called a hybrid. Normally we will take V1 I1 is expressed in terms of V2 I2. But here voltage in the input port, current in the output port is expressed in current in the input port and voltage in the output port. That's why called a hybrid parameter. So V1 equal to H11 I1 plus H12 V2. Similarly I2 equal to H21 I1 plus H22 V2. Now we'll see what is this. These are all the hybrid parameters. H11, H12, H21, H22 are the hybrid parameter. Now we'll see the expression for hybrid parameters one by one. So the same thing is expressed in terms of matrix. V1 I2, this V1 I2, here I1 V2. These are all the hybrid parameters, H11, H12, 21, 22. The individual H parameter may be defined by letting I1 equal to 0 and V2 equal to 0. So by making these two assumptions, we are able to find these hybrid parameters. First we will assume that when V2 equal to 0, output voltage is 0. When the output voltage will be 0, the output port 2 dash is short circuited. When the output port is short circuited, automatically V2 equal to 0. See, refer here, this term V2 is 0. So V2 equal to 0 means the entire term will be 0. So only we have V1 equal to H11 I1. So H11 is nothing but V1 by I1. Brought this I1 in the denominator. So V1 by I1 will be H11. Similarly V2 equal to 0. So this entire term is 0. Only we have I2 equal to H21 I1. So H21 is nothing but I2 divided by I1. So by making output port 2 dash 0, V2 equal to 0. So these two terms are 0. So from that we are able to find the H11 and H21 parameters. Now we'll see in detail. So H11 what we calculated, V1 by I1 by making V2 equal to 0. So this is nothing but V by I is nothing but impedance. Input V1 and I1 input port. So input impedance. What we make the short circuit. So short circuit input impedance. So that is nothing but Y11. 1 by Y11. Right. So this I1 by V1 is the Y11. So here V1 by I1 is there. So it can be written as 1 by Y11. Similarly, H21 equal to I2 by I1. So both are current. So that is called a current gain. Forward current gain. And we are making short circuit. So that short circuit forward current gain. So that is equivalent to Y21 by Y11. This Y parameter is available. Separate video is available. In that, what is Y11, what is Y12 is explained. The separate video is available. So by making output port 2.0, V2 is 0. From the basic equation, we are able to find H11 and H21. Short circuit input impedance, short circuit forward current gain. Now I will go to the and I will see how to find the remaining two parameters, H parameters. So the remaining two parameters what we are making, the input port 1 dash is open circuited. If it is open circuited means current will be 0. Earlier we short circuited, so that voltage is 0. Now open circuited, I1 equal to 0. By using this I1 equal to 0, we are able to find the remaining two parameters. Now we'll see the basic equation. So these two basic equation available. In that I1 equal to 0. If I1 is 0 means the entire term is 0. So V1 equal to H12 into V2. So H12 is nothing but V1 divided by V2. Brought the V2 in the denominator. V1 by V2 is nothing but H12. Similarly, I1 0 means the entire term is 0. I2 equal to H22 into V2. So H22 is nothing but I2 divided by V2. So by substituting I1 equal to 0, we are able to find these two parameters. Now we'll see in detail. Right, what we discussed, H12 is V1 by V2 by making I1 equal to 0. See, these both are voltage. So it is voltage gain. Reverse voltage gain, and it is open circuited. So that open circuit reverse voltage gain. It is equivalent to Z12 divided by Z22. This Z parameter also separate video available. So by using this is related to this expression. H12 equal to V1 by V2, I1 equal to 0, that is equivalent to Z12 divided by Z22. Similarly, H22 from the basic equation we calculated I2 by V2. So I by V is there. So that it is admittance. V by I means impedance. It is output admittance and open circuited. So open circuit output admittance. It is equivalent to 1 divided by Z22. So now we calculated all four hybrid parameters H11, H12, H21 and H22. Since the H parameter represent dimensionally an impedance, admittance, voltage gain and current gain, these are all called hybrid parameters. So all these are available, current gain, voltage gain, impedance, admittance, all these things are available, so that it is useful for finding this in a transistor circuit. Now we'll see the equivalent circuit. This is the equivalent circuit of a two-port network with a hybrid parameter. Input port is the output port, V1, I1, input voltage and current, V2, I2, output voltage and current. Now we'll see all four parameters. This H11. What is H11? Is nothing but short circuit current gain. So this H11 is the short circuit input impedance. So there is a impedance. It is represented as impedance. H12 is nothing but open circuit reverse voltage gain. This is a voltage. It's a voltage source. Voltage gain. So these two are connected in input side. Similarly, in the output side, what we have? H22. H22 is nothing but open circuit output admittance. So that it is connected here. Then H21 is nothing but open circuit. H21 is nothing but short circuit forward current gain, so that it is connected, right? So all the 4 parameters are we have. This is the voltage gain, current gain, impedance, and this one admittance. All 4 parameters. By using that, the equivalent circuit is drawn. So in this video we discuss the hybrid parameters, taking one voltage in the input port and current in the output port, so that is called a hybrid parameter. By using that, from the basic equation, by making short circuit and open circuit, we are able to find the 4 parameters. We come to conclude that all 4 parameters are available: current gain, voltage gain, impedance, and admittance. That will be useful for finding the parameter in the transistor circuit. That is the main application of hybrid parameter. Finally, we discuss the equivalent circuit also. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. All the best for your examination.